This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 2, Lesson 3, Fenestration and Solar Gain. A window carries 3 loads at the same time. Heat conducts through the glass, sunlight pours in as solar gain, and air leaks around the frame. The handbook prints one combined equation that adds all 3. We'll walk each path, see why the solar term usually rules on a cooling day, then work one window. Concept 1. 3 parallel paths. Conduction moves heat through the glass on the temperature difference, just like a wall. Solar admits sunlight through the glass, driven by irradiance, not by delta T. And air leaks around the frame, which is really infiltration. Add the 3 terms, all on the same projected window area, for the net gain. Notice the solar path is the odd one out. It keeps flowing, even when inside and outside are the same temperature. Concept 2. The solar term. The solar heat gain coefficient is the fraction of striking sunlight that ends up as heat in the room, transmitted plus re-radiated inward. It's dimensionless, 0 to 1. Multiply it by the window area and the incident irradiance to get the solar load. Lower coefficient, less gain. That's what tinting and low-E coatings buy you. One warning, the old shading coefficient and solar heat gain factor tables are not in the handbook. It carries the solar heat gain coefficient and nothing else. Concept 3. Where the U factor comes from. A window isn't uniform. The frame and the sealed glass edge conduct more than the center of the glass. So the handbook area weights the 3. Center glass, edge glass, and frame, each by its area, over the projected area. In the example, the frame pulls the whole window value up to 0.50, well above the center of glass 0.35. If a problem instead gives you a rated product U, you'd read it straight from the glazing table, with a separate table for doors. Concept 4. The air leakage term. This is just the sensible load of air leaking through the window. The 60 and the leakage rate turn the flux into a cubic feet per minute. Density and specific heat and delta T finish it. Identical to infiltration. So watch the double count. This is your window's share of infiltration, Lesson 6. If you've already tallied leakage another way, don't add this term on top. Count the window leakage exactly once. Concept 5. Condensation resistance. Separate from load, the handbook rates a window with a temperature index. The inner surface temperature minus the cold outdoor air, over the indoor minus the outdoor. It runs 0 to 1. Higher means the inner glass stays closer to room temperature, so it's less likely to fall below the dew point and fog up. In the example, the inner glass sits at 0.64 of the way from outdoor to indoor. It's a surface temperature metric, not a load term. Setup. A 30 square foot west window on a design cooling afternoon. 95 outside, 75 in the room, a 20-degree difference. The whole window U is the 0.50 WE area weighted. The glazing coefficient is 0.40, the irradiance on the glass 200, and it leaks 0.3 of a cubic foot per minute per square foot. One glyph warning, the leakage here is a flux, cubic feet per minute per square foot, not the effective leakage area in square inches you'll meet in Lesson 6. Solve. Conduction is 300, solar 2400, air leakage 194. Total about 2,900. Look at the split. Solar is over 80% of it. On a sunny cooling day, the glazing coefficient, not the U factor, sets the window load. That's why low-E glass beats a heavier frame. And if you already counted this leakage in your infiltration total, drop that last term so you don't double it. Traps. 5 ways this bites. 1. Solar has no delta T. It's driven by sunlight. It's gain only, and it flows even at equal temperatures. 2. The handbook prints the solar heat gain coefficient only. There's no shading coefficient or solar heat gain factor table. 3. The third term is window infiltration. Count leakage once, not twice. 4. The fenestration leakage is a flux, cubic feet per minute per square foot, not Lesson 6's leakage area in square inches. 5. Use the area-weighted whole window U. Center of glass alone lowballs the conduction because the frame leaks heat. Quick recall. A window carries 3 loads. conduction on the temperature difference, solar on the coefficient and the sunlight, and air leakage that's really infiltration. Use the area-weighted whole window U. Remember, the handbook gives the solar heat gain coefficient only, and count the leakage once. Condensation resistance is a separate temperature index. Golden rule: name the driver of each term before you plug in numbers, and on a sunny day, expect solar to win. Next up, Lesson 4, Internal Gains, Part 1. We turn to the heat sources inside the room. People, giving off sensible and latent heat from an activity table, lighting, and motors, with 3 forms depending on where the motor and its load sit. These are instantaneous gains. The handbook prints no cooling load factor. Everything's at PEPrepEngine.com, cheat sheet, work solution, and a quiz attached here.
The full study guide with every equation and common exam trap is free at PEPrepEngine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.